Welcome back. So on today's agenda, we have some notes on reflection, and then at the very end of the lesson, you guys will have a Google form for homework. By the end of class today, you should be able to describe how a shape moves using reflections. So when we talk about reflections, this means that an image is being flipped. So a transformation in which a geometric figure is reflected across a line, creating a mirror image. That line is called the axis of reflection. So remember how we talked about before that our original figure, we call it the pre-image. So we have this polygon here. And then I went ahead and I reflected this polygon across this line. Because it's being reflected across this line, I'm calling this my axis of reflection. And notice when I flip it across to the other side, I create my new image. And notice that all I've done is I've taken my original polygon, and now instead of it thinking of facing to the right, it is now facing left. Okay. And then each of these points, so like this point will map to this new point. These points are the same distance away from my axis of reflection. And what I mean by that is, let's go ahead and look at this picture here. Oh, I'm sorry. First, let's go ahead and let's play this short piece of the video. Let's go to 108.
Reflect. In this example, the triangle on the right has been reflected, flipped over the dotted line to create a mirror image. Or we can say that the vertices of the triangle A, B, and C has been reflected, flipped over the dotted line to create the mirror image as another triangle having vertices A dash, B dash, and C dash.
Okay, so that video right there, I'm going to go ahead and I'm now going to show this image. So what I want you guys to notice is I went ahead and I took this original triangle, A, B, C, and I reflected that image across the line of reflection. For me is going to be my y-axis. Okay, so this bolded y-axis line here. What I want you to notice is, since this is my line of reflection, notice to get from point A, the line of reflection, I'm jumping how many units? Exactly 1 unit, right? Because I'm going from -1 to 0. So I made one jump. And then notice the same thing can be said of point E. Notice in order for point E to touch my axis of reflection, it makes one jump, okay? And then let's look at point B. To get from point B to that line, that axis of reflection, it's 1, 2 spaces that I'm moving. And then the same thing can be said from point D. 1, 2 spaces that I'm moving. And then lastly, point C, 1 space that I'm moving. Same can be said for point F, 1 space that I'm moving. So I just really want you guys to notice that and pay attention to that when it comes to that axis of reflection, your pre-image point and your new image point should always be the same distance away from whatever your axis of reflection is. So my axis of reflection here, point A is 1 space away, point E is 1 space away in the opposite direction. Point B is 2 spaces away, point D is 2 spaces away in the opposite direction. Point C is 1 space away, point F is 1 space away in the opposite direction, okay? So we have to keep that balance.